Hello again. I'm Eric Schumacher Rasmussen. I'm the conference chair for streaming media events, and I'm also the CMO at Ideas. Welcome to the fourth session of the third day of the eighth Streaming Media Connect. This is our second virtual event of 2022, and we're soon going to be having the second in-person event of 2022. We'll be in Huntington Beach in November for Streaming Media West, November 15th and 16th. The program just went live this week. If you're interested in speaking, please don't hesitate to contact me. You can find me easily on LinkedIn, or I can pop my email address into the chat. And if you want to attend, all the information you need to know to register is right there. Before we jump into today's panel, or this next presentation, I should say, a couple of housekeeping notes. Just for being here, you are entered into a drawing for an Amazon gift card. You know, when we said a couple sessions ago that we'd give it to the first person who guessed the song that our producer Steve plays during the intro, we didn't really, go through all the rules and the terms and conditions. So we're conferring backstage here, and we'll get back to you on that. But we will announce the winner. The one thing that is constant, though, is the winner does need to be present at the end to win. If you have questions for our speaker, please enter them in the Q&A tab at the bottom of your screen. That just makes it easier for us to keep track of them than if they're in the chat. Also, subtitles, transcripts are turned on. Live transcript, which is AI, which means Zoom predicts what you're going to say and then backtracks and corrects it. If you want to turn those off, if you don't need them on, you can go to the bottom of your Zoom window, click on live transcript, and then select disable transcript. And finally, all the Streaming Media Connect sessions will be available on demand Monday at youtube.com/streaming video, or at the link that Steve pops in the chat again. I'd like to thank our diamond sponsor, Media Silo, for making all 3 days of Streaming Media Connect possible. And we've got a short video message from them right now. Thanks again, Media Silo, and thank you to System 73 for sponsoring this Tech Talk. And for the next 25 minutes or so, Daniel Perea from System 73 is going to be talking about how to prepare for large-scale live streams, how to leverage AI to guarantee optimal delivery, and hopefully keep costs down in the process. Right, Daniel?
That's definitely so. Thank you very much, Eric, for the introduction. And of
you bet.
course,
Take it away.
For having me.
You bet. I'll let you take it from here.
Thank you so much. And also thank you all the audience for attending and for enjoying these definitely good talks. And I also want to extend the thanks to Steve and the CAR team that he's doing an amazing job also with the message selection. And by the way, Eric, I think we should keep with the rules that you need to guess the proper music in order to win the $50 Amazon gift. Okay, so we're going to talk today about how to deliver the optimal live experience at scale under any circumstances, okay? We're going to talk about the circumstances. We are going to go a little bit further into the technical details, and we don't have too much time, but I think it's going to be a very good introduction about the usual problems and solutions that are in place in order to deliver live streaming with good quality of experience at scale. So for that, let me share the screen, and if the trust of the systems do not have any issues with that, we'll be able to share the screen with you guys. Okay, so in order to start with this, we're going to do a quick introduction about the items, but if you have missed any information or you have any more further questions or you are more interested in going deeper, we're going to have a webinar on September 1st, 1 week from now, and you will be able to have more in-depth information about what we have been discussing during this talk. And at any point in time, you will be able to scan the QR or just click on the link that Steve very gently has shared through the chat window, or just scan the QR at any point in time. You will have the QR available through the different slides and also at the end during the Q&A. So do not hesitate if you have any questions, either through the Q&A panel that we have available in the Zoom portal, or just join us on the webinar on the next week, and we can go even deeper in those technical details. The topic is going to be mostly about internet congestion and live streaming quality of experience related with that. And here in this specific talk, we're going to do an introduction to that and how to make that solvable, at least tractable at scale and any circumstances like my beloved marketing team wants to put in place. So let's start with an outline, what we're going to cover during the talk. We have 20-25 minutes overall, so it's not too much of a time, but I think we're going to touch on very interesting topics. First of all, let's get a high level overview into the common live streaming issues. And whenever we know them and we have the stage prepared, we start tearing some layers on what is going on under the hood in order to have the full visibility of the delivery chain, so we can start answering the questions about what's going on. Whenever we are in place, we can set up the stage for the optimal delivery, having the right information, making the right decisions. And after that has been introduced, we can discover what is the full potential of the delivery network. Again, QR on the top right-hand side, if you want to go deeper next week, at any point in time, of course, drop the questions in the QA section of the Zoom window. Please do not use the chat, because that is not what we usually track in order to answer the questions. Okay, let's dive right in. Common issues with current live streaming workflows. Of course, whenever you are starting to deal with live streaming, the issue of the quality of experience is paramount. That's not something that I need to tell you. You are very familiar with the fact that if you have an impact on the quality, there's going to be an issue at the end of the day. But what is actually happening under the hood when the problems arise and they are not low-hanging fruits that we all know how to solve? First and foremost, that usually comes with the question of, hey, there is a quality of experience issue and I don't know what it is. Essentially, the quality of experience is uncontrolled, and that means that you don't know why, right? It starts showing up for some reasons. You may have a clue that maybe is related with the limitations in the network infrastructure. It can be at any point in time or any point in the network delivery chain. It can be at the beginning, at the middle, at the end, but usually there is a lack of visibility of what's going on. And sometimes that is even worse to analyze, because that doesn't happen always. Sometimes you need to wait until you are actually in prime time for one shot event, the one that you have been preparing for a long time, or maybe you have a large organic event in your 24/7 linear stream that happens to be related with a global event or a football match or you name it. And that problem only shows up under those circumstances. So it's very hard to debug and to solve for. Of course, under the hood, what is happening is that there are most of the time delivery limitations on the delivery chain. So they may be caused by saturated peering points in the internet exchange points across the whole delivery chain, maybe over even higher on the upstream delivery chain. So we can go all the way into the Cdn shields or even to the origins, and you may have overwhelming origin servers whenever you have a large audience, and that only shows up, of course, when you have a large audience globally or even locally. But at the end of the day, what is happening is that there is an impact on the quality of experience, and that creates an audience churn. Essentially, you have people leaving your event, your stream, and that is essentially an impact on what we all strive to do with the streaming media industry, specifically for live events. And it's not just a rebuffering event that is going to make the people leave. Only a single change on the quality that is perceived by the audience starts to add up during the whole life cycle of the session of a single user. If you have several of them chain, then you start seeing that even if it's completely subjective, you feel a disengagement, and then you end up leaving the audience. So this is really important for audience retention overall. Okay, so let's start with the basics, okay? Just to put the stage on what should we do in general in order to deliver large-scale live streaming events. So first of all, let's start with the usual delivery change for a video workflow for live. Let's talk with a scenario like this that start with the content encoded in different renditions or different qualities, different bit rates, starting from, say, the lowest resolution at 480 or even lower, and then you have different qualities just to match the network capacities of the audience at any point in time. And then you deliver that content through the network, maybe for one or multiple CDNs. It doesn't matter. In this example, we are using several, but the things don't change so much at the end of the day. So let's say, for example, here that we have CDN 1, you are maybe a customer that that is using only one CDN service, or maybe you have multiples. But in the case that you have one, okay, the delivery is going through that. And then the content is going to try to reach the audience, wherever they are, right? It needs to traverse the open internet. Sometimes you have POPs inside the ISP, sometimes you have POPs outside of the ISPs, but at the end of the day, you need to traverse open internet at some stage, either through the origination into the shield, or the shield into the POPs, or the POPs into the audience itself. You are traversing part of the infrastructure that we all share and use for OTT. And that ends up arriving into the end user devices, and they are consumed. Okay, very basic workflow, nothing new under the sun here with what we have been telling. And in the case if you have multiple CDNs, the situation doesn't change so much. Okay, you have CDN 2, CDN 3, doesn't matter. At the end of the day, you will have multiple points of presence across the network to deliver the content through the open internet. Now, such things happening, and then you start to see some issues, of course, and you don't have the visibility what's going on. Something happens along the way. Okay, the CDN should have the content, but it's not arriving correctly to the audience. And maybe it's delivered through this branch over here with CDN 1, if that's the only CDN that you have. And there is some issue along the way. It can be anything, as I mentioned. It can be a peering point that is congested. It can be origin server that is congested because the propagations of the cache misses are going all the way back. Or it may be something else that is happening in terms of availability of one CDN versus the other, or even in the last mile, the ISP is not scalable enough, or it doesn't have enough peering agreements with the CDNs because they are not co-located. You name it, anything can happen along the way. The fact is that there is some issue and you don't have visibility of what's going on, right? And we need to have visibility in order to solve this problem. Otherwise, we are just getting shots on the dark, right? So that's what this box reflects here, the fact that we do not have visibility of what's going on over here most of the time, but we need to have that visibility, right? Okay, so let's start to get a little bit more visibility of what's going on under the hood here. And if you check carefully here between CDN 2 and the audience, the connection that is essentially reflected in green is one link at the end that traverses the network and it fans out into your audience. So just have a look into this green line over here that is kind of a very small tree with 2 leaves, because this is important. The concept of the trees is going to be used across the talk, and let's stick with that for several reasons that we will discuss a little later. So, okay, let's build that broadcast tree, okay? And why a tree? Okay, let's explain the first principles of what we do in the industry when we are delivering content to our audience. At the end of the day, it doesn't differ too much from the traditional era of broadcasting, these good old days when we just turn on the TV and we were receiving the content right away through terrestrial antennas, cable, satellite, you name it, that in the end, unless somebody was breaking the rules with the radio frequency or tampering with the cable, you were getting the content, and you were getting the content always in the quality that it was intended to be received. And what is the underlying infrastructure that was in place at that point in time, and that we are still using to some extent, but even less as we go on, is just a broadcast tree. It's a broadcast mechanism that every time that we need to relay the content from any point in time to another, we have a relaying node in the middle that is making that relay for us. Terrestrial, you have the antennas. Cable, you have the breakout boxes. Satellite, you have the satellites themselves, and then the terrestrial stations, you name it. At the end of the day, this is just an infrastructure that is in charge of relaying the content in order to come from a single point of origination into many points in your audience, right? That's the first principles. At the end of the day, that's what underlies a broadcasting effort, regardless if it's live for terrestrial, satellite, cable, or what we are talking about here, that is OTT, over the open internet. Now, the challenges, of course, comes from the change of the media, but taking it back to the first principles is what is going to give us the advantage of trying to find the solution and then putting the solution in place. So here, we're going to talk about the broadcast tree, and I'm using the term peer-to-peer networks because at the end of the day, in the OTT world, what we have is a network of peer-to-peer nodes. Even if we're talking about traditional CDNs, say you have a single CDN with several POPs across the world, and maybe you have an origin shield that is protecting your origin from being overflowed by all these points of presence. What you have at the end is just a set of peers that are just computational devices, computers, servers, you name it, that are in charge of relaying that content. So here, those nodes will be essentially the ones that are called here fixed, and then they will be relaying the content if we're leveraging them to deliver the content across the network. If we are talking about a scenario that you are a little bit more advanced and not using purely CDN in the traditional fashion, but you're also leveraging the audience itself to relay the content, that frankly, I encourage you to do so, because that's going to solve a lot of the problems in terms of scalability. The only difference is that the computational devices that you will be using are not limited to servers that are under data center or under the control of the CDN in the traditional fashion, but you will be able to use also the computational devices that the audience have in order to make that content closer to your audience and also more scalable for large events. But at the end of the day, it doesn't change. We are here to discuss a technical background about all these problems, and these are common for any kind of infrastructure, regardless if you're using one CDN, multiple CDNs, a combination of one CDN with expansion of the capacity with a peer-to-peer network of end-user devices, or just end-user devices alone. That is still the same. What you have is a network with a lot of computational devices across the geographical region that you want to reach, and you need to use it in the best fashion possible to scale and reach your audience in due time. So what happens under the hood is that you have to make those connections. Either somebody does the connection for you because you rely on an external provider, or the provider is essentially yourself and you need to build that infrastructure yourself. So what you need to do at the end is creating this network in the most efficient manner in order to attend the needs of your audience at scale and with good quality of experience. So, okay, let's continue with this narrative and this abstraction. And here in the slide, we have a combination of fixed and mobile devices, because of course, when we are engaging with the audience, we also have the mobile devices across the across the audience, and then we can leverage them to some extent if we want to. But at the end of the day, they still need to receive the content, okay? Fixed and mobile, you name it, your audience will be there at the bottom of the tree. And then we will get the content from the rest of the infrastructure, and we need to do that in a rightful manner, okay? That's common across the whole industry. But that is just the high level perspective of what's going on under the hood. Of course, we have one layer below that is the actual physical network. And for that, of course, through the open internet, we need to traverse the multiple internet service providers that are actually owning the infrastructure that is connecting all of the nodes in the delivery chain. And this may be just the fact that one CDN and one computational device in general is within one ISP, let's say ISP-A. So over here, we have a couple of nodes in the ISP-A. And in order to reach the rest of the audience, you need to traverse, in this toy example, connectivity between ISP-A and ISP-B that is reflected with this interface here on the diagram. So, okay, fair enough. Still, everything is a toy example. Everything is ideal, but that's the fact. You need to traverse those areas of the network. But then whenever you start going into the live events, and then you start growing, and then you have issues, those issues usually come from the fact that there is some connectivity issue at some point in time in the delivery chain. So, okay, let's go to check the connectivity between those ISPs. You may have several of them, of course, but here we're going to use an example that ISP-A connected to ISP-B in that direction is congested, okay? So the connectivity point between both ISPs that may be on one internet exchange point in the region that you're covering is starting to sweat a little bit, maybe related with your own event, or it can be even related with somebody else's data that is congesting that link, right? So what happens under the hood is that what is going to impact downstream your event is that the audience that is downstream is not going to perceive a good quality of experience. Maybe just a portion of the audience, like we're showing here, or maybe all of the audience if they are all passing through that internet exchange point, or any other kind of network element that is congested. Again, it doesn't have to be an internet exchange point. It can be any other place, just a congested origin shield, or a congested origin itself, or even the last mile when we want to reach the audience. So this is the reality of what's going on whenever we want to broadcast a live event for a large audience and we want to strive for the highest quality of experience. So this is the kind of problems that happen, and that's the things that we need to tackle in order to solve it. So what can we do in order to tackle this? Okay, we have peeled some layers of the network stack, and we want to see these elements of the network happening, and we need to gather that information. And there's a very good question that is just coming from the Q&A panel that is, okay, how can all this information be used to automate the routing of the traffic? We're going to get into there after a couple of slides. First of all, we need to know what kind of data we have to collect in order to make this problem a solution that works for us. So let's jump into that. What kind of data do we need in order to, first of all, start thinking about solving the problem? Because otherwise we are just collecting data at random. Data for the sake of data is not the solution for this. You may have a lot of probes, you may have a lot of telemetry that you may not have at the beginning until you realize that you need to have a problem to be solved. And then you start probing, having information collection and dimensions across a whole lot of dashboards and APIs. But data for the sake of data sometimes is hindering your capability to understand what is the root cause of the problem. Because some of these data have upstream dependencies, like I mentioned in the slide before. Going back here, you may have the perception that these two users are having a quality of experience issue. And you may say, okay, this is ISPB that is having bad capability. And then you start maybe meeting with the ISPs to do capacity planning. And not only that, also do capacity planning with the CDN providers. But that is just adding band-aids to the problem, because these network circumstances can change at any point in time. And even here, some of the audience may be pretty fine for different reasons. So you still need to have the right data, right? So what you need to have is data that is actionable and that is trustworthy to be used as information that will let you know where the problem lies. Okay, so we need to go a little bit deeper into what kind of information is needed to, first of all, make it actionable, and second, make it trustworthy. So what kind of right data is actually valid for you in order to solve this problem? First of all, you need to have quality of experience data, of course, on the end user devices. That is really important, but it needs to be specific about your streaming service. It doesn't matter if you're collecting information from a community that has performance details about a specific region, if that is completely unrelated with your streaming effort. First of all, because your audience may not be the same. Second, and even more importantly, because the technical requirements of your audience may not be the same. It's not the same to have a high quality performance VOD or live stream with a lot of latency, with a lot of buffer in place just to accommodate for that, versus if you are having a lower quality requirements, but lower latency requirements, that makes this a little bit harder. At the end of the day, your audience is what really matters. You need to have visibility of what's happening to your audience. And not only that, you need to have visibility not only about the quality of experience on the last part of the tree, you need to have visibility to what's going on delivery chain upstream. So you need to have visibility about the capacities of the network across the entire delivery path, including the last, but also the middle mile, right? And of course, you need to have that information to be accurate, just to reflect that the quality of experience and performance data is not tainted by the bottlenecks that may come earlier into the delivery chain. And Rick had a good question, that is, what tools, software are used to harvest this data? Traditionally, an SDK, in any kind of analytics approach, you usually get an SDK that is just a small small piece of either JavaScript framework or the specific flavor of language for the native platforms in order to just integrate into that. There are several providers, also including us. I'm taking here, of course, a shot into our marketing efforts, but of course, there are many providers that can provide you visibility on the analytics of what's going on under the hood. Or you can start collecting it yourself. That's another option. But usually nowadays, this market is already established in order to collect this information. It's not worth it to reinvent the wheel. And that allows you, of course, to have the information about what's going on, right? Now, we need to see what we do with that data. Let's say for a moment that we have walked this road and we have collected information that is right, that is accurate, and that is actionable. So now we need to decide what we do in order to solve this problem. And for that, of course, we need to build that broadcasting tree that we mentioned before, but we need to build it correctly. And we need to build it correctly, because otherwise we are going to traverse those congested paths that we just mentioned before. So we need to be flexible, we need to be agile, and we need to be proactive in order to accommodate for those certain changing circumstances. So going back to what is required in terms of tools and software about what is the good method to collect this data, regardless of what kind of provider you use, doesn't matter if it's us, another pitch for the marketing guides, or another provider, you need to collect data from the end user devices as well as network performance levels via an SDK. SDK is the method to collect that information accurately from the end user side, and then you can go all the way upstream. Not only that, in order to do this for live properly, you need to have a very fine granularity on the data that you collect, at least every second. Why? Because even in normal latency circumstances, the buffer that the players have to accommodate for any issue on the delivery chain is usually 30 seconds, maybe 20 seconds. Sometimes you go lower to 10, 5 seconds if we're talking about low latency. So if you only have a sampling period, a granularity on the data that you collect that is on the order of minutes, or even if you're talking about 5 seconds, you are not seeing what's going on between those 5 seconds, 1 minute slots. And then what you see is that suddenly there is an impact on the quality of experience of your audience. In order to be proactive and not reactive, you need to be agile on the data collection. Of course, that implies that there is a lot of information being collected, but in this case, data is king. This is nothing different from any other kind of industry and all the talks that have been happening before. This is really, really important. And at the end of the day, of course, you need to have the visibility of the whole network performance. It doesn't matter that you have the quality of experience only on the end user if you don't have the visibility of where on the delivery chain that issue appears. So you need to have the visibility not only on the last mile, but also between the end user devices and the POPs on the CDN upstream. Okay, so with this information in place, let's see how we build this solution. And as we have mentioned, the broadcasting tree, that is the paradigmatical broadcasting optimal method to deliver the content, is a go-to option. But we are going to show why different method is not so much of an efficient, at least from our experience. You can start solving this problem in the internet, in OTT, having multiple providers of the information at the same time in order to make this tractable. But at the end of the day, what you will end up doing is having either a plethora of CDNs that is going to increase the load on your origination system, or you will have a plethora of end user devices connected to each other that at the end of the day, what introduces is a kind of a fake redundancy feeling that you will have multiple sources to get the content from, but you will have a significant increase in the overhead in the terms of the usage of the network, because you are collecting information from different sources. And even if you multiplex that in time, the discovery effort of where knowing the content is also an overhead, you name it. At the end of the day, we need to stick back to the first principles, that is the broadcasting tree, because that is going to be the most efficient way in order to deliver the content right. But you need to know where the right path is. Bear with me again, but here we are coming from the stage that we have collected information and we already know where the good path to deliver the content is. So we can do the right-hand chart over here that is building the most efficient tree. Even in this toy scenario with one single CDN and 5 end user devices, you will see the large amount of connections that are between the end user devices in the mesh scenario versus a traditional tree. So whenever we have this in place, we can talk about what is the outcome of doing something like this. So whenever you build a tree like this, you are able to make an efficient use of the links that are available. Let's say in the example here on the right, it's a very simple toy example, but we are going to talk a little bit more realistic production tree a little later on. We'll have a CDN, essentially whatever node in the network, but it can be a origination system or you name it, with 5 connections saturating the link to the CDN. Of course, it's a toy example. This will not happen in reality with only 5, but you get the gist of it. If we are going to 10, 100, 1000, at some point we are going to hit the limit of the infrastructure. But here, if you have the right and wide usage of the links at any point in time, whatever is capable of the network to be delivered, if you choose it wisely, you will be able to deliver it correctly. And at the end of the day, of course, this introduces a reduction of the cost because there is a fewer load on the upper levels of the broadcasting tree that is usually the most expensive areas of the network. And if you do something like that, then you start striving the benefits of this kind of decisions. Here's just an example of what kind of quality of experience can be achieved with this kind of technologies. You can achieve actually a 94%, this is actually production data, by the way, 94% of the audience in the highest rendition in an event with organic audience at any point in time with no previous preparation. Of course, with 78% of the traffic being delivered on the bottom part of the P2P network, in this case with end user devices. So it's a very compelling solution to the problem whenever you have the visibility and then you have the actuation to make it in place. Answering the question that I have on the Q&A panel, that is how all this information can be used to automate the routing of the traffic. Of course, whenever you have the information in place, you know where the bottlenecks are and where the usage of the network is underutilized, and you can exploit it a little bit more, right? So this information is allowing you to decide where the traffic to go to. And of course, going back here to the requirements, you will need to have real-time data collection of the data in a centrally managed network optimization place, because if you do that completely distributed, you don't have the visibility. You need to have the information collected and make the right decisions in a central place. And then, of course, you are able to strive to make something like this. Let's go into a specific detail of what is going on under the hood, and then we will see what's the outcome. This is still a toy example, 50 nodes, but you're starting to see the potential of these kind of approaches. Again, doesn't matter if you're using CDNs with peer nodes in the server side or in the end user side, the first principle approach applies to everybody. If you arrange the tree correctly, you will be able to do something like this. Here we can see an event that is starting, and then we are seeing the usual organic audience of people coming by to the stream, and we see a peak on the load of one of the elements of the network delivery chain. In this case, it's a single CDN, but whenever you start optimizing the network connectivity, you start to see that the load decreases and the traffic that goes to the P2P network becomes the majority, up to the point that you can reach even more than 94% of the efficiency over there. And that, of course, creates the benefits that we just mentioned over here. Everybody's able to watch to the best extent of the network capabilities. Of course, there are real other limitations that are unavoidable. If you are on the last mile with low quality, okay, there's nothing to do with that. You need to improve your last mile connectivity. But if it's upstream, okay, this is a solution for that. And these are more realistic visualizations of what's happening under the hood. Here again, with 3-tiered trees in terms of seeing the progression between an initial incoming of audience and how it grows with time. First example, a toy example still with 8 viewers with this kind of connectivity, and then growing with the audience as they come about, 240 viewers or 1,050 viewers. These still are more examples, small examples. In production, of course, we reach audiences that are much larger than this, and we need to accommodate for that. But the potential here is very, very compelling. This is the kind of solutions that make the problem solvable and tractable, and you write the benefits about this. And again, if you want to have more information about this, always have the Q&A section and we will tackle that, or join the webinar that is available on the QR. Just to wrap up, visibility on the quality of experience data of your audience is paramount. Do not use community data. That's not going to serve you well. Visibility of the network capacity, not only the quality of experience across the delivery path, is really important in order to solve the problem, and accurate quality of experience data and performance data to enable the automatization of the optimization methods. If you want to try to make this proactively before the quality of experience impact happens, that's what you need to do. You need to automate all this process. Doing it by hand with capacity planning and meetings with the ISP and the CDN providers is going to be a band-aid until something wrong happens. With that, I'm going to jump into the Q&A section. Probably I will tackle a couple of more questions that are still available on the thread. And if we run out of time or you want to understand more or go a little bit deeper, do not hesitate to join the webinar on the QR code and also on the link that is on the chat. And we will have to cover those grounds a little bit deeper. I'm going to tackle a couple of questions that are on the Q&A panel. One question is about how does a P2P network work inside a telco? That's a very good question. There are methods to handle this correctly. And the way that we approach to the problem is working with the data that we collect to understand that telcos are part of the ecosystem. ISPs are part of the ecosystem. We need to operate and work with them. But instead of having a capacity planning meeting for a large event for each and every customer that doesn't scale, what we do is we leverage the data. So for example, if we detect that the most efficient and more convenient way to share the data across different peers is inside the ISP network, let's say one single ASN, we optimize for that. And then we keep the connectivity within the ISP network. And then those interfaces that I mentioned in the slides, where there is a small interface that is an internet exchange pinpoint, we minimize the amount of traffic that goes through that connection, but we do it automatically instead of doing capacity planning. Okay, more questions coming in. How much time is required in advance in order to scale up your P2P network for large live events? We have the process automated, so we need to orchestrate the systems in a scalable manner. Of course, we don't need to put the infrastructure of the content delivery itself. We are just orchestrating in this kind of solutions the connectivity. So it's very easily for us to scale because we don't need to bear the burden of the content, but we definitely need to put infrastructure in place to scale elastically with cloud resources. We are using cloud providers like anybody else at the end of the day. Another question says, essentially, if I understand correctly, thanks to this technology, the more people that are live watching my stream, the better the content is delivered. Is that correct? That's correct. That's a very good question. And that's quite opposite from the traditional infrastructure delivery methods. Whenever you have a larger audience, usually the strain comes into the infrastructure and the capacity. And here is completely opposite. With the audience, we are able to grow the capacity of the event itself. Rick clears that says that this is clear and that the performance using data is very nice. So thank you very much, Rick, for your kind words. We have another question coming by about how you determine when to switch CDNs. Is there downtime needed to make this happen? No, there's no downtime needed. There are different mechanisms to do the switching the CDN. And bear in mind that this is not only switching between CDNs, but also switching between end user devices. This is completely automated. And I strive you to recommend that if you implement something like this, you need to make this completely automated. Otherwise, it's going to be unbearable. The amount of data that comes in a tree with only 1,000 devices is completely unmanageable. And if you want to segregate that by ISPs, then you start to make compromises about this. Another question, how we set up a test or proof of concept with real production traffic? Quite easy. It's just integrating the SDK and tracing it out with your audience. So it's very, very straightforward. The integration of the SDK is one line of code into the player. And we have seen customers doing that in 1 hour. Again, that's not necessarily the thing that you need to do with us alone, but it's definitely very, very convenient. And another question, can your analytics solution determine where all the network issues are occurring? We need to do that in order to be proactive with these kind of solutions. We continuously monitor, as I mentioned, every second, the quality of experience and the performance data across the whole network. And that is allowing us to have the visibility. We also offer analytics dashboard to surface that information upstream and make it available to our customers. But in general, if you want to solve these kind of problems, you need to have that kind of visibility. And that is a given that by doing so, you will have the analytics to show it. And another question that goes over here, how does delivering streams via Starlink terrestrial affect the quality of the streams? That's a very good question. Starlink, at the end of the day, is just a connection of devices that are floating across the globe. So essentially, those nodes that I just mentioned in my slides before, the only difference is that they are essentially orbiting the Earth on a low Earth orbit. Those, of course, are on the network layer, but whenever we operate on the application layer with the end user devices or the POPs or the nodes, the same happens. Of course, if Starlink goes into your orbit and then you see an increase on your capacity of the stream, and then you lose a little bit of coverage with the satellite, and then your last mile link decreases a little bit of quality, what is going to happen is that the player will detect that automatically and lower the quality accordingly, because you have a limitation on the last mile. But that's exactly the same as if you are in your mobile device, mobile phone, and you are roaming between one antenna and the other, and your 4G, 5G connectivity goes a little bit lower, and then you need to adapt for that. That is purely last mile connectivity. And another question, I think that will be the last one before we close off, because we have been investing quite a bit of time, is we are looking into a CDN switching solution, but it seems like your solution could alleviate most of the needs for a CDN switcher. Is that correct? Yes, that's correct. CDN switching can allow you to introduce a little bit of redundancy if you have a blackout on one of CDN, but for performance requirements, this CDN switching is going to take you only the minimum common denominator between the different CDN providers that you have. And you may go with 1, 2, 3 CDN providers, but we have seen customers that go with 8 CDN providers and still they don't solve the issues because they have a global event and it's unbearable, the kind of arrangements and contracts that you need to get in place. And then still you need to have the manual switching or even automated within CDNs. But if the problem is about the capacity overall, you need to have an expansion of the capacity. So you need to go to the end user devices too. So yes, answering your question, this is a solution for a CDN switcher that is, in my humble opinion, much, much better than just adding more capacity linearly. This grows exponentially. So I think we have covered all the questions, and I hand it over to Eric, and thank you very much for your attention.
Thank you very much. That was terrific, as witnessed by the amount of questions in the Q&A. So thanks again, Daniel. You've got all the information, and by you, I mean the audience members have all the information you need to learn more about System 73. Speaking of audience members, the winner of the Amazon gift card, well, Mike Fitzpatrick got it first, but he won earlier today. So the winner of the gift card is Garrick Huey, who correctly identified Way Back Home by Junior Walker and the All-Stars. Now, we know we have no way of proving or disproving that you use Spotify, or I'm sorry, Shazam to identify it. But you know what? Who cares? Enjoy. Watch your email for that gift card information next week. Thanks again to System 73 for sponsoring this session, Media Silo for sponsoring all 3 days. We will wrap things up with Streaming Media Connect in 30 minutes. Actually, no, it's about 45 minutes, 47, with Chris Paff and an all-star panel talking about interactivity in online video, coming from both the technical angle and the business and content angle. Should be a great discussion. We'll see you then. Thanks again.